Hey everyone, and welcome back to the Deep Dive. Today, we're
Yeah.
going to be diving headfirst into a topic that is sure to make your brain do a few backflips.
Mm.
Plasma and the mind-blowing idea of an electric universe. It's a perspective that challenges some of the things we think we know about space, and trust me, it's a wild ride.
It is.
Now, before we launch ourselves into the cosmos, hit that like button and subscribe so you don't miss out on any future deep dives.
That's right. What we're doing today is looking at the universe through a different lens. We're questioning the assumptions and digging into some truly fascinating ideas about the role of electricity in the cosmos.
All right, let's start with the basics. What exactly is plasma, and why is it so important in this whole electric universe theory?
Think of plasma as the rebellious teenager of matter. You've got your solids, liquids, and gases. Those are pretty well behaved. But plasma's got energy. It's buzzing with charged particles, and it makes up most of the visible universe. It's the stuff of stars, nebulae, those dazzling auroras, you name it. And here's the kicker. It conducts electricity.
Okay, hold on. So you're saying that most of the universe isn't made
Hmm.
of the stuff we see and touch every day. It's this electrifying, supercharged plasma.
Exactly. And this is where the electric universe model really takes off. It says that electricity and plasma play a much bigger role in the universe than standard theories give them credit for.
So the universe isn't just governed by gravity. It's like a giant electrical circuit. That's a lot to process.
It is a big shift in perspective, but it explains a lot of things that traditional astronomy struggles with. The electric universe model suggests that some of the fundamental assumptions we've made about space might be, well, off.
Give me an example. What kind of assumptions are we talking about?
One is that electric fields and plasma discharges,
Yeah.
like lightning, aren't really important in shaping the universe.
Mm-hmm.
The mainstream view is that gravity and magnetism are the big players, and electricity is a minor character. But the electric universe model says, hold up, electricity is a major force to be reckoned with.
Okay, that's interesting. So it's like we've been focusing on the supporting actors when the lead role belongs to electricity. What's the other assumption the electric universe model challenges?
The other big one is about redshift. In traditional astronomy, redshift, the stretching of light waves as they travel through space, is always seen as a measure of distance. The farther away something is, the more its light is redshifted. This is a cornerstone of the Big Bang theory, which says the universe is expanding.
Right. The farther away a galaxy is, the faster it's moving away from us, and the more redshifted its light becomes. But you're saying the electric universe model disagrees.
Right. It suggests that redshift might not always be about distance. There's evidence that redshift can be caused by other factors, like the age of the light or the strength of the electric fields it's passed through.
So redshift might not be as straightforward as we thought. Things that appear incredibly far away based on their redshift might actually be much closer.
Exactly. And there's a scientist named Halton Arp who shook things up by finding quasars,
Yeah.
super bright, high redshift objects thought to be billions of light years away, like right next to galaxies with low redshift.
Wait, so things that should be incredibly far apart in space, based on their redshift, are actually hanging out together. That seems like a big problem for the idea that redshift always equals distance.
It definitely threw a wrench in the works. Arp's observations suggested that these quasars and galaxies might be physically connected, even though their redshifts implied that they were vastly different distances away.
Okay, my mind is officially blown. So we have a universe that's mostly made of this crazy energetic plasma, and the way we measure distance might be flawed. This electric universe model is turning everything upside down. But how does it explain something like a star? We're taught that stars are giant nuclear furnaces, powered by fusion in their cores. Does the electric universe model agree?
Hold on to your hats, because this is where things get really electrifying. The electric universe model proposes that stars aren't powered by nuclear fusion at all. They're actually giant cosmic balls of lightning.
Stars are balls of lightning. I'm going to need you to elaborate on that one.
Imagine a star not as a furnace, but as an electrode in a galactic scale circuit. Electrical currents flowing through the galaxy converge on these stars, creating immense heat and light.
So stars are powered by electricity from the galaxy itself. But wouldn't gravity just cause them to collapse in on themselves if they weren't held up by the outward pressure of nuclear fusion?
Another great question. The electric universe model suggests that the constant flow of electric current through the star provides the outward pressure to counteract gravity. It's like a continuous self-sustaining electrical discharge.
Okay, I'm starting to see how this could work.
Okay.
But if stars aren't giant nuclear reactors, How do they form in the first place?
Instead of forming from the gravitational collapse of gas and dust clouds, the electric universe model proposes that stars are born through a process called electrical fissioning. Imagine a larger star pinching off smaller portions of itself due to electrical forces.
So stars can essentially give birth to other stars. Yeah. That's wild. And does this explain why we see so many binary star systems in Pei, two stars orbiting each other, and gas giants orbiting close to their stars?
Exactly. The electric universe model provides a more elegant explanation for these common astronomical configurations. It's like a cosmic family tree with stars sparking into existence through electrical interactions.
Okay, I'm hooked. This electric universe model is blowing my mind wide open. But I have to ask me, if this theory is so compelling, why haven't I heard more about it? Is it just a fringe idea?
It definitely challenges the mainstream scientific paradigm, but it's gaining traction as more and more scientists and researchers start to see the inconsistencies in traditional models and the explanatory power of the electric universe.
So it's not just a bunch of people wearing tinfoil hats.
Not at all. There are legitimate scientists and researchers around the world who are exploring the electric universe model and finding that it offers compelling answers to some of the most enduring mysteries of the cosmos.
Well, I'm definitely on board for this wild ride.
Yeah.
But I have another question. If those craters on the moon and planets aren't all from impacts, what caused them? Were they zapped into existence by giant space lasers?
Space lasers. Tempting, but not quite. Remember those powerful electrical discharges we've been talking about? The electric universe model suggests that many of those craters are actually scars left by colossal electric arcs.
You're saying that those massive, perfectly round craters
Mhm.
were carved out by lightning bolts from space? That's insane. But it does kind of explain those weird, sinuous channels we see on Mars
Yeah.
that look like giant, dried-up riverbeds.
Exactly. Those sinuous channels, called reels, are a classic sign of electrical scarring. They're tough to explain with erosion or impacts, but they match the patterns we see in electrical discharges.
Wow, I'm starting to see craters everywhere now. But if these electrical events were so powerful, is there any evidence of them happening now in our solar system?
Look no further than Jupiter's moon, Io. It's the most volcanically active body in our Thor system, spewing plumes of sulfur and molten rock. But here's the thing. These eruptions often show signs of electrical activity.
So those volcanoes are basically giant plasma guns. That's a sight I'd love to see. But wait, I thought volcanoes were caused by heat from a moon or planet's core. How does electricity fit into that?
The electric universe model proposes that electrical currents flowing through Io interact with Jupiter's incredibly strong magnetic field. This generates intense heat, leading to those spectacular eruptions. It's like Io is stuck in a cosmic tug-of-war between electrical and magnetic forces.
Okay, I need to take a moment to let all of this sink in. This is revolutionizing everything I thought I knew about space. But if Earth is also part of this electric universe, does that mean we're at risk of getting zapped by some stray cosmic lightning bolt? Should we be investing in planetary-scale lightning rods?
Don't worry, we're not about to be turned into cosmic toast, but you've hit upon a really important point. Earth is indeed electrically active, and our ionosphere, that layer of the atmosphere that bounces radio waves, is a key player.
Right, the ionosphere. I thought that was just, hanging out up there,
Yeah.
reflecting radio signals. What's so electrifying about it?
The ionosphere is far from passive. It's teeming with charged particles, constantly buzzing with energy, from solar radiation, cosmic rays, and even our own weather. Think of it as a giant electrified shield, protecting us from the harsher aspects of space.
So it's like our planet's personal force field,
Yeah.
powered by electricity.
Pretty cool. But how do thunderstorms play into all of this?
Believe it or not,
Uh-huh.
thunderstorms act like enormous natural batteries. They generate massive electrical potential differences between the tops and bottoms of clouds. And guess what? These storms are directly linked to the ionosphere, creating a global electrical circuit. Wait a minute, Hari. Are you saying that lightning isn't just a light show? It's part of a planet-wide electrical system? I'm starting to feel like I'm living in a science fiction novel.
You're catching on. This global electric circuit is constantly humming with energy, and it's crucial for maintaining our planet's electrical balance. But here's where things get really interesting. Within this circuit, there's the possibility of plasmoids.
Plasmoids.
Oh, yeah.
Okay, now you've officially lost me. What in the world are plasmoids?
Picture a self-contained ball of plasma, swirling with energy. That's a plasmoid. They can form in different ways, but in the context of this global electric circuit, They could be created by the intense electrical and magnetic forces generated by thunderstorms.
So these plasmoids are like mini stars zipping around in our atmosphere.
Yeah.
Do they pose any danger to us? Could they explain some of those strange, unexplained aerial phenomena people have been reporting for centuries?
You're on the right track. There's growing evidence suggesting that plasmoids might explain some, but though certainly not all FOFO sightings. Remember those reports of objects making impossible maneuvers, appearing and disappearing suddenly? That's all consistent with what we know about plasmoids.
Whoa, are you telling me that some UFOs might not be alien spaceships,
Yeah.
but naturally occurring balls of plasma? That's kind of a bummer,
Yeah.
but also incredibly cool.
Uh,
But how could a plasmoid just vanish? That seems to break the laws of physics.
Plasmoids are inherently unstable. They can dissipate quickly as their energy fades, or they can merge with other plasmoids, creating even more energetic events. We're still studying them, but it's clear they can do some pretty mind-boggling
It's
things.
fascinating. I was a bit skeptical about the whole electric universe thing at first, but now I'm totally hooked. But let's get back to those UFO sightings. If some are plasmoids, how do we explain the reports of alien abductions?
Really?
Were people hallucinating because they got too close to a cosmic lightning ball?
Now we're venturing into more speculative territory, but there's a thought-provoking idea that plasmoids might induce electromagnetic hallucinations. The intense electromagnetic fields they generate could potentially mess with the brain's electrical activity, creating vivid, dreamlike experiences.
Electromagnetic hallucinations. That sounds like something straight out of the Matrix. So people who claim they were abducted by aliens might have been zapped by a plasmoid that scrambled their brains.
It's a provocative idea, and one that's difficult to prove or disprove, but it does offer a potential explanation for some of the stranger details in abduction accounts. Missing time, feelings of paralysis, bizarre sensory experiences.
Okay, that's officially the most mind-blowing thing I've heard all day.
Yeah.
We have these plasmoids, potentially causing UFO sightings and electromagnetic hallucinations.
Yeah.
But what about those massive craters on Mars? Surely those couldn't have been caused by a simple lightning bolt.
Remember those thunderbolts of the gods, depicted in ancient art and mythology? Jupiter hurling lightning bolts as weapons? Well, there's a chance. Those stories were inspired by actual observations of powerful electrical discharges between celestial bodies.
Wait, are you suggesting that planets and moons can exchange lightning bolts? Like some kind of cosmic tennis match? What would even trigger that?
Yeah.
And how could they generate enough energy to carve out craters the size of cities?
We're still piecing together the puzzle, but the electric universe model proposes that these discharges could be triggered by close encounters between celestial bodies or disruptions in galactic electrical currents. And remember, the energies involved in these cosmic electrical events are on a scale we can barely comprehend. We're talking about forces that can reshape planets.
This is making me feel very small and insignificant, but also incredibly excited. So those ancient myths about gods hurling lightning bolts might be based on real events. That's a history lesson I never expected. But if these electrical encounters can be so destructive, what about Earth? Are we at risk of getting scarred by a cosmic thunderbolt?
It's possible, though how likely is still being debated. But there's intriguing evidence that might point to past electrical encounters in Earth's history. One example is the Martian hemispheric dichotomy, the stark difference in cratering patterns between Mars's northern and southern hemispheres.
Hold on, what does Mars have to do with Earth? Are you saying that whatever happened to Mars could happen to us?
The Martian hemispheric dichotomy is a puzzle. The northern hemisphere is relatively smooth, while the southern hemisphere is heavily cratered. Impact theory struggles to explain this, but electrical scarring could provide a more plausible explanation.
So you're saying some massive electrical discharge might have blasted one side of Mars, leaving behind those craters, while the other side was mostly untouched. That's a terrifying thought.
Oh.
But what kind of event could cause that much electrical damage?
That's the million-dollar question, some researchers believe. A close encounter with another celestial body might have triggered a massive electrical discharge, leaving its mark on Mars. Others suggest a sudden surge in galactic electrical currents could have played a role. We're still in the early stages of understanding these cosmic electrical events, but it's clear they can have a profound impact, literally, on planets and moons.
Okay, I'm officially convinced that the electric universe is a force to be reckoned with. But let's shift gears for a second. You mentioned earlier that stars can form through electrical fissioning. What exactly does that entail? Is it like a star splitting in two, like some kind of cosmic mitosis?
It's not as simple as splitting in half, but you're on the right track. Think of a star as a giant rotating ball of plasma with electrical currents flowing through it. Under certain conditions, these currents can become unstable, causing the star to pinch or constrict in certain areas.
So the star starts to look like a cosmic dumbbell. What happens next?
As those pinched regions become more and more concentrated, they can eventually break away from the parent star, forming smaller, independent bodies. These offspring could be anything from companion stars to gas giant planets, depending on their size and energy.
So stars are giving birth to other stars and planets through these electrical contractions. That's amazing. But if this is happening all the time, shouldn't we be seeing new stars and planets popping up everywhere?
We are seeing new stars and planets forming, but the process takes time. Vast amounts of time. Stellar evolution, even in the electric universe model, is a slow and gradual process unfolding over millions, even billions of years.
Okay, that makes sense. But what about those mysterious nebulae, those vast swirling clouds of gas and dust scattered throughout the galaxy? Are they influenced by electrical forces too?
Nebulae are a prime example of plasma in action. Those intricate filaments and swirling patterns are a dead giveaway. The electrical currents are flowing through those cosmic clouds. And those vibrant colors. They're not just pretty to look at, Liv. They're a direct result of atoms being excited by electrical discharges.
So those nebulae are like giant cosmic neon signs powered by electricity. That's incredible. But what about black holes? Everyone's fascinated by them. Do they fit into the electric universe model?
Black holes are a bit of an enigma, even in the electric universe model. There's no doubt they exist, but their nature and properties are still hotly debated. Some researchers propose that they might be the ultimate sinks for electrical currents, pulling in matter and energy from their surroundings and concentrating it into incredibly dense regions of space.
So black holes might be like cosmic vacuum cleaners, sucking up everything in their path. That's a scary thought. But what about the Big Bang? Does the electric universe model have an alternative explanation for the origin of the universe?
The Big Bang is one of the most fundamental concepts in modern cosmology, but it's not without its critics. The electric universe model challenges the idea of a universe that suddenly exploded into existence from an infinitely dense point. Instead, it proposes a universe that's eternal and constantly evolving, with no beginning and no end.
Whoa, an eternal universe. That's a pretty radical departure from the mainstream view. But how can a universe exist without a beginning? Where did all the matter and energy come from?
That's a question that has puzzled philosophers and scientists for centuries. The electric universe model doesn't claim to have all the answers, but it does offer a different perspective. Instead of a universe created in a single cataclysmic event, it envisions a universe constantly being shaped and reshaped by electrical forces.
This is all so mind-blowing. I was starting to feel like I need a degree in astrophysics just to keep up with all of this. But let's bring it back down to Earth for a second. We talked earlier about those plasmoids zipping around in our atmosphere. Are they just random occurrences, or could they be harnessed or controlled in some way?
That's a fascinating question. Plasmoids have the potential to be incredibly powerful sources of energy, and researchers are exploring ways to create and control them in the laboratory. Imagine harnessing the power of a miniature star. The possibilities are endless.
That's incredible. We could be on the verge of a new era of energy production. Powered by plasmoids. But I have to ask me, what about those UFOs? If some of them are really plasmoids, how do we know for sure? And what about those alien abduction stories? Are they all just electromagnetic hallucinations?
The nature of UFOs and alien abductions is a complex and controversial topic, and the electric universe model doesn't claim to have all the answers. But it does offer a different perspective, one that encourages us to consider alternative explanations and to question long-held assumptions.
Okay, I'm definitely going to be looking at the sky with a whole new sense of wonder and maybe a little bit of apprehension now. But let's wrap things up for today. What are some of the key takeaways from our deep dive into the electric universe? What should our listeners be thinking about as they contemplate the mysteries of the cosmos?
Here's what I find truly remarkable about this exploration. First, we need to embrace the idea that the universe is far more electrically active than we've been led to believe. Second, the electric universe model reminds us that science is a process of ongoing discovery, and that questioning long-held assumptions is crucial to advancing our understanding of the world around us.
I couldn't agree more. We need to be open to new ideas. and willing to challenge the status quo. After all, the universe is full of mysteries, and who knows what incredible discoveries await us as we continue to explore its depths.
Precisely. And remember, even seemingly settled scientific theories are open to reinterpretation. In light of new evidence, the electric universe might not have all the answers, but it certainly raises some intriguing questions that deserve further investigation.
Well said. This has been an absolutely mind-blowing deep dive, and I'm sure our listeners are buzzing with excitement. Or maybe that's just the electromagnetic fields from those plasmoids.
You've got a point there. But in all seriousness, I encourage everyone to keep exploring, keep questioning, and keep your minds open to the infinite possibilities of the universe. Who knows what other electrifying mysteries await us out there in the vast expanse of space?
Well said. And on that note, may I just leave you with a final thought to ponder. If the universe is truly a giant electrical system, what are the implications for our understanding of life itself? Could life be more than just a biological phenomenon? Could it be an intrinsic property of the electric universe? It really is mind-boggling to consider that life itself could be intertwined with these cosmic electrical forces. But before we get too existential, let's bring it back to something a bit more familiar, comets. We've always been told they're just dirty snowballs left over from the early solar system. Does the electric universe model have a different take on these icy wanderers?
It absolutely does. The electric universe model sees comets not as passive chunks of ice and rock, but as active, electrically charged bodies interacting with the sun's powerful electric field.
So instead of just being nudged around by gravity, comets are actually plugged into the sun's electrical system. I'm picturing them like cosmic kite surfers, riding the solar wind.
That's a great analogy. As a comet approaches the sun, its icy surface begins to sublimate, releasing gas and dust. But the electric universe model suggests that this process is dramatically enhanced by electrical interactions. The comet's nucleus, which is thought to be highly conductive, acts like a giant cathode, drawing in electric current from the sun.
So those spectacular comet tails and jets we see aren't just caused by melting ice, they're driven by electricity.
Precisely. Those outbursts of gas and dust are likely triggered by electrical surges within the comet itself. It's a cosmic light show powered by the electric universe.
This is making me want to hop on a spaceship and get a closer look at these electric comets. But for now, let's ground ourselves back on Earth. Are there any everyday phenomena that demonstrate the principles of the electric universe right here on our own planet?
You're surrounded by them. Think about lightning. It's not just a random atmospheric discharge. It's a vital part of Earth's global electric circuit, connecting the ionosphere to the ground.
So every time I see a lightning bolt, I'm witnessing the electric universe in action. I never thought of it that way.
Exactly. And those mesmerizing auroras that dance across the polar skies, those are another stunning example of the electric universe at work.
Auroras are one of nature's most breathtaking displays. What causes those shimmering curtains of light?
They're created when charged particles from the sun, carried by the solar wind, interact with Earth's magnetic field and get funneled down into the upper atmosphere. These particles collide with atoms in the air, exciting them and causing them to emit those beautiful, colorful lights.
So those auroras are like giant natural neon signs. Powered by the solar wind. That's incredible. It's amazing how something as seemingly ordinary as electricity can create such awe-inspiring displays.
It really is. And it speaks to the interconnectedness of everything in the universe. The electric universe model emphasizes that we're not dealing with isolated objects and events. It's all part of a vast, interconnected web of energy and matter, interacting through electrical and magnetic forces.
That's one of the most fascinating aspects of the electric universe model. This idea that everything is connected. It shifts our perspective from seeing the universe as a collection of separate parts to understanding it as a unified whole.
Exactly. It encourages us to see the universe not as a random collection of objects, but as a dynamic and interconnected system shaped by the flow of electricity.
This has been an absolutely incredible deep dive, and I feel like we've only just scratched the surface of this fascinating topic. But before we wrap things up, is there anything else you'd like to share with our listeners about the electric universe model?
I would just encourage everyone to stay curious and open-minded. The electric universe model may not have all the answers, but it offers a fresh perspective and challenges us to think beyond the conventional paradigms. Keep exploring, keep asking questions, and never stop looking up at the stars with a sense of wonder.
Beautifully said. This deep dive has certainly left me with a profound sense of awe and a renewed appreciation for the mysteries of the cosmos. It seems like the more we learn about the universe, the more we realize how much we still don't know.
That's the beauty of science. It's a never-ending journey of discovery, and the electric universe model is a testament to the fact that there's always more to explore, more to learn, and more to question.
Well, on that note, we'll leave our listeners with a final thought to ponder. If the universe is truly an electric universe, what other secrets might it be hiding? What other incredible discoveries await us as we continue to delve deeper into the mysteries of plasma and electricity? Until next time, keep those minds open, keep those questions coming, and never stop exploring the wonders of the cosmos. Don't forget to like and subscribe for more mind-blowing deep dives. See you on the next one.